Okay, I want to mention that I made a video that showed how to complete the square without giving you any direct background information. We simply just ran right into it and started working on it. If you want to see the formulas that are going on in the background for completing the squares, they are written right here. So in order to complete the square of x squared plus bx, you need to add a b over 2 squared to the equation so that it can be written as a perfect square. The result of this expression is x squared plus bx plus b over 2 squared. And in this form, if you rewrite a quadratic in this form, it'll always be factorable. And that's what allows you to write it as a perfect square, which is what is down here. Perfect square meaning it's an identical pair of terms times each other. So yeah, an identical pair of things times each other. Like 2 times 2 are perfect squares because 2 is the same thing as 2. So these are the general formulas. Just a reminder, when they're talking about b, what they're talking about is from the standard form a times x squared plus bx plus c equals 0. They're talking about the b value, that thing multiplied by the x term. Now, how can we apply the rules to rewrite something as a perfect square? If you want to write everything out in detail, there are 6 steps. If I were you, I'd just take a screenshot of this and save it on your desktop rather than copying it all down. So let's go through these. First step I would like you to do is to write these in standard form. Let's pretend this equals x, might as well be an equation. We like equations. So this is already written in standard form because you've got your ax squared here, your bx there, and then your c, which is 1. Next step, you need to divide both sides by a to make sure the coefficient term is 1. You don't have to do anything on this one because you already have a 1 for a, so there's no point in dividing everything by 1. Complete the square by adding b divided by 2 squared and subtracting it. The subtracting piece is the second step, all within step 3. So let's take a look at b divided by 2 squared. So our b in this example is 6. So to figure out b divided by 2 squared, we're going to take 6 divided by 2, and then we're going to square it. When you do that, you're going to get 9. So it says to add 9 to our equation. So if we've got our equation up here, I'm going to rewrite it on the left. It's going to be x squared plus 6x, and then I'm going to write this plus 9 here. So plus 9. Now here's one of the things you need to make sure you keep straight. If you have a plus 9, you need to also subtract 9. Why would I do that? I'll show you in a moment, but for the most part, the reason we have to have the minus 9 along with the plus 9 is because we need to keep everything the same on this side of the equation. You can't just add something and assume nothing will happen. You have to also subtract to keep it in balance. And then we've got the plus 1 equals 0. Can't forget about that plus 1. Now, the reason this formula works is because when we added that plus 9, it created a situation where we can factor that plus 9, the 6x, and the x squared into a perfect square. If I were to factor this, and I ask myself, what 2 numbers multiply to 9 that add to 6, it would be 3. Notice that's also what b divided by 2 is. That's always the case. So I could rewrite this part as x plus 3 squared. Then I've still got the minus 9 and the plus 1, so I've got minus 8 equals 0. I want to mention something real quick. It's important to know this. What I've written here we've already completed the square. We're pretty much home free. This general form is called vertex form. It is in vertex form. The vertex of the parabola can be pulled out from this formula. The general formula would be a times x minus h squared plus k, where the vertex is hk, which means the vertex in the example above is going to be minus 3 and minus 8. And no, that is not a typo. The x value of the vertex is minus 3 because the general form is a minus h. So we have the opposite of that here with the plus 3. So there are two purposes for completing the square in our class. One is you can rewrite a quadratic equation in vertex form and quickly figure out what the vertex is. The other is you can actually solve this equation using this method. And here's why. Let's go ahead and take this equation and solve it. What I want to do is I want to get the term that's being squared by itself, because then I can use the square root property to solve it. So I want to write x plus 3 squared equals 8. So I added 8 to both sides to get that x plus 3 squared by itself. Now, think about what you need to do to undo something being squared. You've learned that you can take the square root of both sides. Don't forget the plus or minus. So in this case, you're going to have x plus 3 equals plus or minus the square root of 8. And you can keep going to simplify this thing. So I want to get x by itself because I'm solving for x, so I can subtract 3 from both sides. When you do that, you get x equals negative 3 plus or minus the square root of 8. Now you are almost done. So close. You can taste it. Because you only have to do one more thing, and that is to simplify the square root of 8, which you should know how to do because it's got perfect squares in there. And you know how to take the square root of perfect squares. Just a reminder, perfect squares are things like 4, 9, 16, 25, 1,296. I just threw that out there. Okay, so find the biggest perfect square that goes in the square root of 8 and rewrite this as x equals negative 3 plus or minus 2 square roots of 2. So you'll be able to break this down into the square root of 4 times the square root of 2, which turns into 2 square root of 2,